Okay, so if we're trying to find, let's say we're trying to find the cosine of this angle theta, and the terminal arm is in the fourth quadrant. So let's say that we are given an x-coordinate of 3/4. So what we want to do is we want to find out what the y-coordinate is, and we want to use the equation of a circle, right? And of course, with 1 being the radius, that's the equation of the unit circle. So let me just... All right, so let's say we put 3/4 in here, and we're going to solve for y now. So we have y squared equals 1 minus, this is going to be 9 over 16 when we square that and subtract it. Y squared is going to be 16 over 16 minus 9 over 16. So y squared is going to be 7 over 16, right? And so y is going to be root 7 over 16. Now, is it going to be positive or negative in the fourth quadrant here? Well, the y has to be negative, doesn't it? So it looks like if we have an x-coordinate of 3/4, we would have a y-coordinate of negative root 7 over 16 or negative root 7 over 4. Okay, so let's write that in there. Over 4. You guys with me so far? Just interrupt me if you have a question, or if you notice I've done something wrong. Heaven forbid, or if you have a question. So if I've got this now for my point, all right, now that's a point that's on the unit circle. I know that because these 2 points satisfy this equation, which is the equation, of course, of the unit circle. So I can use this data, this point, and I can find out what cos is. Now, because r is 1, right, I know that cos is the first coordinate. So it goes cos theta, sine theta for points that are on the unit circle. So this angle theta, cos theta, is 3/4. We're actually given that. Now, can I find the sine of theta? The sine of theta is negative root 7 over 4. And what about finally tan of theta? Can I find tan of theta? Well, what you want to remember is that tan of theta is sine theta divided by cos theta. So I'm going to go negative root 7 over 4 divided by 3 over 4. That's sine divided by cos, which is, I can flip and multiply this now. The 4's cancel out, and I get negative root 7 over 3. Okay, so here I have cosine of theta was given. Sine of theta I found using the equation of the unit circle, and tan theta I found as well now that I have the 2 points. So just one more thing you could do for confirmation here, right? You could turn your calculator on, make sure you're in radians, and well, I guess we could find out what angle this is and just see if it's reasonable. So let's do second function cos of 0.75, or 3/4. What does that give us? 0.722. Okay, so 0.722 would be this angle over here, 0.722. And now that's not the angle we're looking for, right? But that could be a reference angle for this one, couldn't it? Because remember the cast rule. The cast rule says cosine is positive here and cosine is positive here. So this theta is actually 2 pi minus 0.722, and that would be reasonable. So 2 pi minus 0.722. 7, I'll put some more decimals in there. 2, 4, 7, 8, okay? And so I get 5.56. So it looks like our theta in reality is 5.56 radians or so if we just round that. And of course we could check to see if sine of 5.56 is anywhere near negative root 7 over 4. So let's try it. Sine of 5.56 is negative 0.66. Okay, well, what is negative square root 7 divided by 4. Look at that. Pretty much the same. That's the same value. And so it looks like these are lining up. We'll do one more. Tan of negative root 7 divided by 3. Sorry, that's bad. Tan of 5.56, right. Negative 0.88 and negative root 7 divided by 3 is negative 0.88. So it's all matching up here. Okay, so there's our angle, and here are our trig functions. And what were we given? We were just given a visual on the angle, and we were given the x coordinate. So that's how you can find all that. Okay. This is from the chapter 4 chapter test, and this is obviously number 15A we're going to do. So we want to recognize that this is in the pattern of a quadratic. It's trinomial, and it would look like this: 3w squared minus w minus 4 equals 0. You see, we have 3 times tan squared minus tan. So tan is our common part there. So if we just substitute a variable in there, this might be a little bit easier to factor. And of course, we want to factor. We can't get w all by itself because it's in separate terms there, and we cannot combine them to one term. So using just intuition, I guess we could take a look at this and realize that 3w has to come from 3w squared has to be 3w times w. It's prime. Those are the only two factors. And of course, you always want to split the squared variable into both brackets, right? And so 4 has a couple options. We could do 4 and 1 in any combination of positive and negative there. We could do 2 and 2. So we have to try and figure out how we can get a negative 1 when doing FOIL. So I'm going to suggest this. I'm going to suggest the 4 here and the 1 here. Why? Because 3 times 1 is 3. 4 times 1 is 4. So the difference between 3 and 4 is 1. That's how we're going to get the negative 1. The only thing we have to kind of run through our brain is, is it going to be positive or negative? And so it looks like this has to be a negative, so we'll make the bigger one negative and the smaller one positive. Okay? So hopefully that is making sense. If you're wondering about factoring quadratics, you might have to go back and watch another video on that. But this is apparently factored. We can double check. 3w times w is 3w squared plus 3w minus 4w minus 4. Combine those, you get 3w squared minus w minus 4, and that's of course what we had. So this is factored, and when we get to this point, we use the zero product principle, right? So 3w minus 4 equals 0, and w plus 1 equals 0. Would be a good time to resubstitute our tangent back in here. So I'm going to take w, and I'm going to rewrite that as tan theta. Because that's what we substituted really back here, right? We let w equal tan theta to make this factoring a bit easier. So we have this, and we have this right here. So if we solve for tan theta, we get here 4 over 3, and over here tan theta is equal to negative 1. So it looks like we could have exact values for this one. And how do I know that? Because in the unit circle, the values for sine and cos are identical at every every other multiple of 45 degrees, right? So these 4. Here, tan is positive 1, because it's root 2 over 2 divided by root 2 over 2. Here, tan is negative 1. Here, tan is positive 1. And here, tan is negative 1. So tan is negative 1 at, now we're looking at negative pi to positive 2 pi. So tan is positive here. Okay. And negative tan is negative 1 there. And it's also negative 1 here at this angle. See, from there and there. So when we look at this factor, where's tan negative 1? Well, we also have to go back to this point as well in the negative. So that's negative 45, let's talk about the negative one first, or let's do radians, I guess. Negative pi over 4. And just go ahead and interrupt me if you have a question here while we go. But again, this is the negative direction. Here's 0, and I'm going back pi over 4, because that's where tan of theta is negative 1, so negative pi over 4. I'm also going to go in the positive direction now over to here. So this is 1 pi over 4, 2 pi over 4, and that's 3 pi over 4. And then if we keep going over to this one again, where we see it's negative 1, so we got 1 pi over 4, 2 pi over 4, 3 pi over 4, oops, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Okay, so that takes us from negative pi all the way through to positive 2 pi for this factor. We do the same for the other one. And 4 over 3, that's 1.333. 4 over 3, I don't know, is that going to be on the unit circle here? We might have to do approximate values there. So with our calculator, you just turn that on and you go second function tan of 4 divided by 3 to get the angle. So 0.927 is going to be the first quadrant angle. So we've got theta 0.927, right? And so we have to think about, are there any other places on the unit circle that this is going to be true as well? So positive, so positive 0.927, that's going to be, or sorry, it's not there, but positive 0.927 out there. So positive 0.927. And then where else is tan positive? Well, the cast rule says this. So tan is positive over here as well. So guess what? We're going to use this 0.927 as a reference angle, and we're going to find this one. Okay? And that's going to be pi plus 0.927. That's going to be our other angle there. And we're going to do a negative one as well. So we're all, this, you know, these questions can get a little bit long, but again, I'm explaining every single step here, so it's going to take me a while. 4.07. Okay, so we've got this one and this one as well. And then if you notice, and I'll try and use a different color here, but if you notice, we went positive direction, right? We also have to go negative direction back to this one, negative, right? So that's negative. So how do we find that? Well, again, reference angle, 0.927. So we got to go around to negative pi plus 0.927. Go around to negative pi and then add 0.927. So the other one is negative pi plus 0.927. Negative pi plus 0.927. Negative 2.21 is what I get. Negative, what was that? 2.21. So it looks like we'll have to double check this, but it looks like so far I've got this as an angle approximately, this as an angle. Again, these are all approximate with the decimals, and this one, and then these three exact angles right here, there, and there. So it looks like 6 in total. I'll just let me just double check my work here. Chapter 4 practice, chapter tests for pre-calculus 30.